Hello and welcome. This is part B, and we're just going to jump right into it. If you haven't seen part A, you should go back and watch that one first. And here we go. Okay. One advantage to getting old is I find that every day I get more and more efficient at misplacing things. At this rate, in a couple of months, I'm going to be an expert misplacer. We've got our 50 ohm resistor here. Now I'm going to bring this thing up, power it up, make sure it works. I'm going to take some voltage readings, and here we go again. Oh, there it is. I'm going to take some voltage readings. I'll check the voltage drop across this pilot lamp. I'll check the voltage drop across a couple of the tubes, and if I'm happy with what I see, we'll just go ahead and throw a 120 ohm resistor in here. And if I'm not, I'll come up with an alternative plan. I've got, resistors I could put in parallel with 150 ohm to raise the value a little bit if it needs to be. Or I could parallel this up a little bit with something and lower the value if it needs to be. After all these years, who knows? Is the tube draw exactly 300 milliamperes, so on and so forth. But the beauty is this resistor will not be stressed. It will be running at less than half its rated power. I could put it here, here. It would fit in here. I could put it on top of the chassis over here. There's plenty of options to mount this, and I can break the filament string anywhere I want. It doesn't have to be here at the rectifier like that is, where it comes into the, I could make this a solid connection and break it here or here, anywhere I need to break it, put the resistor in. That's a good convenient location where the heat won't bother anything and it's safely out of the way. So let's stop yakking and let's start pouring some angry pixies into this thing and see what happens. Okay, the radio's turned on. I'm going to start bringing the pilot light is lit. See what happens. Volume's all the way up. There's 40 volts. The current's actually dropping. Oh, now it's coming back up. As the tube filaments warm up. No smoke yet. Starting to hear a little bit of a hum. Guess that's from the variac, not from the radio. A little bit of crackling from the speaker. There we go. Yeah, maybe that. Let's bring the voltage up. Well, I'm drawing a lot of current, almost 300 milliamperes. I'm going to have to switch off the dim bulb and go full bore here. And that pilot light looks awful bright to me. Cord's getting nice and warm and we're drawing 1/2 amp. We did have some activity. Boy, that cord smells funky as it warms up. Let's drop back down. We had activity down here at 80 volts, 90 volts. Let me get something to poke with. What I'm probably going to do here, where's all my alignment? Ah, this will work. This is insulated. Ah. I wonder if I've got a bad 25L6. Or did I miss a bad solder joint on the tube? Remember I said it looks suspicious. I did touch up a couple of them. Oh, yeah, see it get brighter just then? Something just stopped. Yeah, I think we got a bad tube. we may have a heater to cathode leak. Along with a scratchy tuning condenser. I wonder if we have a shorted tuning condenser. This is called percussive maintenance. Yep. Yeah, I think we've got an internal short on that tube. You can see the light get real bright, like current's coming in from where it shouldn't be coming in from. So I'm going to see if I've got a 25L6. And I'm going to do some work on that tuning capacitor. We'll take a 3000 shim or something and go in between each of the plates and make sure that they're not rubbing. So I'll be back when that's done.
Glad to have you. Thanks a lot for stopping by. It is the Sean Hannity Show. My name's Joe Pags, and for Sean, 1-800-941-7326.
Okay, looks like the speaker is going to be okay. The tuning capacitor, it was just dirt. It wasn't a dragging plate, it was just dirt. I hit it a couple more times with the deoxit and then blew it out with some blow-off duster. And it's all over my bench now. It's a mess. I need a paper towel. But it solved the problem with all the scratchiness in the tuning capacitor. That's gone. We put a new 25L6 in there, and looks like we'll have to send another one to the happy hunting grounds. We can't leave that tube in there because if that heater to cathode short gets any worse, you saw the light get bright every time that happened. If that thing went full dead short, we could take out 2 or 3 other tubes. So I can't leave that in the set, sad as that may be. Boy, this deoxit stuff is slimy. I'll have to wipe it down with Windex. Sorry about getting in front of the camera. But anyway, see, no more scratchiness. Nice and quiet now. The pilot lamp looks good. It doesn't seem to be extremely bright, so I guess that dropping resistor is doing its job. In fact, let's measure the voltage across that lamp. That's one leg of it. And where's the other one? Okay, so it's black and it's white. So the other leg is here. Alright. I'm going to use this meter. And we'll put this on volts AC 10. Because it certainly should be below 10, otherwise the lamp would have exploded at this point. So I'm going to go from there to there. Alrighty. Whoa! Alright. We got more capacitors to change. Something just went, oh yeah. That one just spilled its guts. So, boy, yeah, it's hot. I am going to disconnect the power from this thing, change the rest of the capacitors, and we'll install, excuse me, we'll install the dropping resistor. Yeah, boy. That's why those caps have to go, folks. That's why we don't leave them in there. The rest of them gotta go. We'll change that cap we'll do an alignment and we'll present the final product when I'm done. I'm not going to bore you with changing all the caps and mounting the resistor. I'll just show it to you when it's finished. Okay, so that's all recapped. I don't have any across the line caps. It won't be in here till Friday, so I temporarily stuck a 600 volt orange drop in as an across the line cap. It would probably be fine, but when the right ones get here, I'll swap it out. But it's not like this thing's in any danger of becoming more dangerous if the cap fails. It's already connected directly to the line, so. But we'll change it out. You remember I told you I check the filter caps. I always change the coupling cap, and I always clip the across the line cap when I go to work on these sets. Well, that guy right over here, yeah, you're the one telling me to hurry up because I'm taking too long. I never disconnected the across the line cap, and that's the one that went thermonuclear on us. I'm glad I was sitting right here in front of it when it happened. No harm, no foul, but that could have taken out several of the tubes, or at least one of them, if it had gone full dead short. But it was right on the verge. It was spitting wax and it was squealing. And so remember, when you're bringing these things up, to make sure that they're working, cut that across the line cap. Just cut it. You don't need it in there to test the radio. But those will go into my to be restuffed pile. I have taken a bunch, or not a bunch, I've taken some important critical voltage readings. I was worried about the dial lamp. It's sitting at 5 volts. That's beautiful. That's perfect. The radio's playing well. It's drawing 46 watts at 118 volts. 390 milliamperes. I should write that down. 0.39. Yeah, it's pretty steady on 390.
And China futures are.
So we'll write that down. 0.39 amps. And the reason I'm taking all of these voltage readings is when I change this resistor out to the fixed 120 ohm one, I want to make sure that everything's the same. I don't really know. I could take a current reading across this cord and do some more measurements, but I've got my critical voltage. I got 75 volts AC here. I got 50 volts AC here across this heater. It's a 25 volt tube. That means it's exactly where it should be. So the series string is seeing the right voltage. The lamp's seeing 5 volts because of the choice of this resistor. 120 volts DC here, 95 volts DC here. And when I change out the resistor, we'll double check all those readings and make sure everything's right. That cord stinks, I gotta tell you. The smell coming off of this thing is just, it isn't utterly unpleasant, but it's just weird smelling because it's getting warm. It's not incredibly hot. Well, yeah, it's, when I do that, it starts getting pretty warm. So what I have to do now is put the resistor in. I'll cut this shaft at the same time when I've got it downstairs and I'm doing, the drilling. I'll get my Dremel out and cut this shaft down to the correct length. Somebody cut it. I don't know why they didn't cut it the right length. Okay, I'm going to put the resistor in it. Take some more voltage readings. I'll show you when that's done, and that'll be it except for the cabinet. And I don't know when I'll get to that. I'm not a dead tree carcass guy, so that's going to take me some time to figure out how to do all the veneer work. I am definitely not David Tipton when it comes to that. That guy just does amazing stuff. If you haven't watched his videos, just look for David Tipton and watch some of his videos and see the stuff that he resurrects. It's incredible. Alrighty, this should be writing the final chapter on this Triad radio. We have the 120 ohm resistor mounted here. We have a brand new polarized cord on the unit. We've connected the second set of contacts on the switch. And so now we have a circuit that looks like so. Our 120 volts coming in is switched both on the line and on the neutral side. So when the set's shut off, nothing's connected. Even if the plug is wired backwards, the set will be inert. We've bypassed our resistor up here, took it out of the circuit. So much for our curtain burner. That'll be joining the rest of the asbestos out in the garage here shortly. And I broke the filament string here. Initially this resistor came in and was connected to the 25Z5, but now that's a straight through shot down to the other end of the string, and I broke it there. And the reason I did that, one, this was a nice convenient location away from everything else. There's nothing on top that the heat will bother. Turn the camera down a little bit here. It's in this area right here, so there's nothing the heat will bother if that resistor gets a little warm. And I was able to lift the lead off of this pin of the tube and just move it over, and there was actually enough wire for me to wrap around and solder, and I ran another line back down, so it was a nice convenient spot to put the resistor. I've done ohm meter checks, and I did a low power up on it, and now it's good and cold again. And what I want to do is I'm going to plug it in, take the cord here and undo the little tie. I want to plug this in at full power and turn it on, and what I'm expecting to see is, make sure this is off, yeah, the pilot light is probably going to bloom. I'm expecting that to have a pretty good flash, but I'm betting that none of the tubes are going to bloom. Is that going to be, maybe I should turn it up, try it up this way. I want everything to be in frame here when I do this, because I'm expecting little or no blooming on any of the tubes because of the resistor. And I left the email downstairs. Let me go grab it. We found it. I got a nice email from Larry Thomas. We've had a couple of exchanges about an FM tuner that he was working on. And he's going to buy some of the Anatherm 1 amp units, even though they're going to be running well outside their normal range, you know, on these sets, because these only draw about 300 or 400 milliamperes. He figured he'd do some experiments and see how bad the voltage drop was. Now at 50% current, they're 1.9 ohms, so they might not be too bad at 25% current, but he's going to make some checks. He's going to try some experiments with using something like the 50L6 or the rectifier tube to also add some warmth to it. And he said he was willing to give a couple of the manufacturers a call and see if they would be willing to make a production run for a volume, you know, for a certain volume of these. So we'll keep our fingers crossed. Thanks, Larry. Appreciate the effort, my friend. And thank you for watching. Okay, back to this thing. My Variax off. Okay, I didn't want to stick my fingers under there. What I want to do is turn this thing on cold and watch to see if there's any tube bloom. Let me get my bench cookies down here, bench dogs. Are we in frame there? Oh, good. That worked out pretty well. Okay, dim bulb is off. Radio, ow, I gotta cut that shaft yet. Radio is off. I'm gonna turn on the Variac. It's already set for 120 volts. And again, I'm expecting the dial lamp to give us a pretty good flash, but hopefully none of the tubes bloom. And they didn't. The bulb bloomed pretty good, but tubes are coming up nice and slow. So that resistor that we've replaced in the line cord is doing its job. We'll let it come up to temperature.
Forget it. It is pitch black because the canopies of the trees are so big. The moonlight and the starlight can't come through. I told you that funny story everyone loves to mock me for, where my kid You cannot. It's an old saying, but it applies to the junk. You cannot see your hand in front of your face. Now, what am I talking about?
It's definitely getting warm.
This is going to apply to this Mitchell Page story. You're going to hang on to this.
But not horribly hot. It's certainly not going to get any hotter than the tubes. And we'll give it a minute for everything to temperature stabilize, and we'll take some voltage readings and see where we stand. Yeah, it's getting warm. It's going to be dissipating a good, 20 watts. So there's going to be some heat on it, but like I say, it's going to be in an area where it's not going to cause a problem. And this set is designed to run with a resistor and provide the correct voltages. So, got to be careful. There's line voltage right there. It's tickled me once already. Part of the filament string. Okay, let's see, where's my voltmeter? DC volts. Go up here on 150 volts. And we should have 120 on the capacitor right there. Put this on DC, untangle some stuff. What do we got here? 117, we're a little low. Let's come up to 118 down here. Whoop, 120, 121, come on. That meter response is awful slow. Okay, almost 120. Make sure the meter's got zeroed. We should have about 95 over here. It's a little bit low. It's 90 volts. What I'm really wondering, I want to go to volts AC here. Stupid camera went beep and shut down on me again. Okay, across my 25Z6 pins 2 and 7, I should have 25 volts. So 8, 7 is right here. Gotta be careful. Pins, good thing I'm on an isolation transformer. Pins 1, 2. We've got 26 volts maybe. Our 25 L6, pins 2 and 7. Let's see, that's 1, this is 2, this is 7. Come on, get on there. We've got a little under 24 volts on that one, so they're not going to drop exactly what they should be, but that's a pretty good number. Let's see, 6SJ or 6SK7. Let's go with that one. Pins 2 and 7. That should be 6 volts. I'm going to go down a range. 1, 2. Oops, get on there. 1, 2, and pin 7. And we've got 6.5 volts, give or take. It's supposed to be 6.3, so I'm pretty happy with that. I think I'm going to leave that alone, actually. I don't care too much about the pilot lamp, and I know that resistor is, what was the number? I forget what that resistor here measured. It's good and toasty, too. That was a little high in value, so that would bring our pilot lamp voltage up. I'm content. I think I'm going to call this set done, except for the cabinet work.
Well, then, you take it.
Your husband passed away after you had a baby?
No, my baby passed away.
Oh my gosh, honey, I'm so sorry.
Yeah.
He decides. You're broken.
charge you no commissions and leave you no choice. At Interactive Brokers, you do have a choice. You can choose to
Okay.
pay no commission.
I guess we can call that one done. Put that one to bed. We'll do the cabinet work at some point down the road. That'll be a nice winter project when I'm snowed in and there's no place to go. Too old to ski, too old to snowboard. I guess I could do a little cross-country skiing. But I'd rather be in Thailand. Doesn't look like that's going to happen this year, though. Damn new variant of the virus going around. Okay, I'm the radio mechanic. Hope somebody found the information in this video a little bit helpful. And we'll be back shortly with the General Electric set, which is another strange power supply. Actually, I'm looking forward a lot to diving into that set with the one with the auto transformer on it. And I better not touch those. And we'll take you along for the ride as we figure that one out. Oh, and just before we go, Old Goat 64 sent me an email the other day. Hello, Goat. And said that on one of his sets, he's replaced the dropping resistor or the ballast with a capacitor. And I used to shy away from doing that. The beauty of using a capacitor is they don't get hot. But I used to worry about the capacitors failing and going short. And indeed, I had a friend that happened 2 years ago, and it took a tube out because the capacitor died, where a resistor normally fails open. But then I got to thinking about it when I went to bed that night. And I said, if you use a modern polyester film capacitor as the dropping capacitor, these are supposed to be, they're supposed to be by design, they fail safe. If they start to short, they usually blow away part of the film inside. So I wonder if anybody out there has any experience with using these as droppers for the filament strings in the sets. I'm still leery of using a cap, but maybe somebody out there who's smarter and knows more about polycaps has an idea or an opinion on that. And maybe I'd get brave and try it on one of these sets. Instead of a resistor, we'll use a capacitive dropper for the filament string. Okay, that's that. I'm going to call this one done. And thanks for coming along for the ride. Appreciate it. Appreciate all my viewers. And we'll see you soon with the GE Radio. Bye now.